Students, in this video let us discuss about electrostatic potential and capacitance chapters 2024 solved paper. So on May 9th shift 1, he asked the question, 3 capacitors of capacitances 10 microfarad, 5 microfarad and 20 microfarad are connected in series with 14 volt DC supply. The charge on 5th microfarad capacitor. He is asking to find the charge on 5 microfarad capacitor. So what he said, he connected 3 capacitors in series with a DC battery of 14 volts. When capacitors are connected in a series, what is the effective capacitance formula? 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. Now 1 by 10 C1, C2, C3, 1 by 10 plus 1 by 5 plus 1 by 20. So that is LCM 40. We get 10 4s are 40, 5 8s are 40, 22s are 40. We will get 14 by 40. So C effective will be 20 by 7. Okay. So 2 7s are 2 20s are. Right. Now C effective is 20 by 7. Now, what he asked in the question, he asked for 5 microfarad capacitors, the charge on 5 microfarad capacitor. So, Q is equal to C effective into V. C effective 20 by 7 into V is 14 volts. Right? So, 7 2s are, so 20 into 2, 40 microcoulomb is the required answer. Hope you understood. Now next, let us go for the next question. The half of the space between the plates of capacitor of parallel plate capacitor is filled with a medium of dielectric constant. And the dielectric constant 4. The capacitance is C1. If 1/3 of the space between the plates is filled with the medium of dielectric constant 4, capacitance is C2. If in both cases dielectric is placed parallel to the plate of a capacitor, then C1 is to C2. What he said did he took parallel plate capacitor, right? Now first in case 1, up to 1/2 distance, that is d by 2 distance, 1/2 distance, he filled with some dielectric material of dielectric constant 4. And he placed that dielectric parallel to the plates of capacitor itself. And in case 2, what he said, nearly d by 3 space he filled with the dielectric material of dielectric constant same 4. Now what he is asking, if in both cases dielectric is placed parallel to the plate of capacitor, he is asking to find the ratio of C1 is to C2. So first, area, if A is the area of plates, D separation between the plates of capacitor, then capacitance of parallel plate capacitor is epsilon naught A by D. Now with dielectric thickness, we write as C is equal to epsilon naught A by D minus T plus T by K, where K is the dielectric constant, T is the thickness of a dielectric material. Alright. Now, in case 1, he filled with the thickness up to d by 2 space. So the thickness becomes T is equal to d by 2. Half of the space he filled with the dielectric material. Now substituting that in the required formula, epsilon naught A by D minus in place of T d by 2 plus in place of T d by 2. Here K is there, I wrote it. Now d minus d by 2, nothing but d by 2 plus d by 2k. Now 2k is the LCM, we will get dk plus d. Now I am taking d as common, k plus 1. Now this 2k goes into the numerator, but epsilon naught A by d is nothing but capacitance. So 2kc by k plus 1. So k is 4. Substituting that, we get 8c by 5. Right? Now in the second case, what he did, he filled up to d by 3 distance. So T we are taking as d by 3. 1/3 he said in the problem. In the problem he said 1/3. 1/3 of space. So we are taking d by 3. And now in a same formula, in place of d, we are substituting d by 3 plus d by 3k. Now d minus d by 3 is 2d by 3. Now LCM is 3k. So 2dk plus d by 3k. Now epsilon naught a 3k, it will go into the numerator. Now I am taking d as common. So 2k plus 1. So 3kc by 2k plus 1. So dielectric constant is 4. So 3 into 4 into c by 2 into 4 plus 1. So we will get 12c by 9. That is nothing but 4 by 3c. Right? Now what he asked, finally he asked to find the ratio between C1 and C2. So substitute C1 and C2 values, you will get 6 by 5, which is the ratio, 6:5. Hope you understood. Now next, a 10 microfarad capacitor is charged by 100 volt battery. Now it is disconnected from the battery and connected to another uncharged capacitor of 30 microfarad. During this process, the electrostatic energy lost by first capacitor. He is asking to calculate electrostatic energy lost by the first capacitor. So in the first case, what he said did, the first capacitor 10 microfarad is connected to the 100 volt battery. So now C1 10 microfarad, voltage 100, energy stored formula half C1 V square. So micro means 10 to the power of minus 6. So half into 10 into 10 to the power of minus 6 into 100 square. So on solving, we will get 0.05 joules. Right? Joules. Now next case 2. Now he disconnected this from the battery and connected uncharged capacitor of capacitance 30 microfarad. Now here when we see this, it is nothing but the series connection. So for series connection, the capacitor, effective capacitor 1 by C equal to C2 plus C1 by C1 C2, or C effective equal to C1 C2 by C1 plus C2 is the required formula. Now here energy lost formula delta U. Energy losses, delta indicates the change in energy or lost in energy. Half C, in place of C. Actually, what is the formula? U is equal to half C V square is the formula. This is the formula. Half C V square. In place of C, as they both are connected in series, we are writing the series effective capacitance C1 C2 by C1 plus C2, and potential becomes V1 minus V2 whole square. But we are disconnecting the battery now, so V2 will be equal to 0. Now delta U equal to half C1 C2 by C1 plus C2 V1 square. Now substitute all values. C1 10 into 10 to the power of minus 6. Now C2 30 into 10 to the power of minus 6. Minus 6, 10 to the power of minus 6 means micro. Now 100 square by C1 C2. Now if you simplify, you will get 3.75 into 10 to the power of minus 2 joules. Right? Now next question. The two capacitors of capacitance 1 microfarad, 2 microfarad can separately, how much they can withstand the potentials? 6 kilowatt and 4 kilowatt. So 1 microfarad capacitance capacitor can withstand 6 kilowatt potential, and 2 microfarad capacitance capacitor can withstand 4 kilowatt. So now the total potential, they together, if they are connected together in series, సిరీస్లో కలిపితే మరి అవి ఎంత పొటెన్షియల్ని విస్టాండ్ చేయగలుగుతాయి అని అడుగుతున్నాడు. సో ఇది 10th మే షిఫ్ట్ 2లో అడిగాడు. సో C1 he gave as 1 microfarad, C2 2 microfarad. సో maximum potential withstand by C1. C1 ఎంత విత్స్టాండ్ చేస్తుంది? 6 kilowatt. సో V maximum ఏమని రాస్తాం? నౌ C is equal to Q by V ఫార్ములానే యూజ్ చేసుకుంటున్నాం ప్రతిదానికి. సో Q maximum by C1. సో Q maximum equal to V1 maximum C1. So V1 is 6 kilo. Kilo means what? 10 to the power of 3. So 6 into 10 to the power of 3 into C1 1 microfarad. No. So micro means 10 to the power of minus 6. We will get 6 into, so 3 minus 6 minus 3. 6 into 10 to the power of minus 3 coulomb. Now next, Similarly, if we do C2 V2, we will get some, how much is this? 4. And how much is this? 2. 4 twos are 8. 8 into 10 to the power of minus 3 coulombs we will get. So C1 V1 maximum is less than C2 V2 maximum. Now here, when C1 and C2, what he said, series lo kalpadu ani antunnadu. When he connected in series, the charge on each capacitor will be equal. No, this is series connection. In series connection, what will be same? Charge will be same throughout the circuit, series circuit, and is equal to the maximum charge the combination can withstand. Now what we have to find out, when we connected these both in series, so how much potential they can withstand, ఎంత potential ని అవి భరించుకోగలుగుతాయి, అవి potential ని withstand చేయగలుగుతాయి. సో CR, series combination no, C2 C1 by C2 plus C1. So C1 C2 value substitute చేయండి, 2/3 into 10 to the power of minus 6 ఫారడేస్ వస్తుంది. సో V maximum కనుక్కోమన్నాడు, Q maximum by CR. సో Q maximum ఇక్కడ కనుక్కున్నాం, 6 into 10 to the power of minus 3 by CR, 2/3 into 10 to the power of minus 6. సో సింప్లిఫై చేస్తే 9 into 10 cube volts వస్తుంది. సో V maximum is 9 kilowatt. Right? Now next, a capacitor of capacitance. Now another thing, మరి మీకు డౌట్ రావచ్చు, ఇక్కడ C1 V1 ఉంది, C2 V2 ఉంది, మరి నేను మాత్రం I substituted only 6 into 10 to the power of minus 3 instead of 8 into 10 to the power of minus 3. I can substitute. No, I'm not substituting. Why? Means here what we said, it is a series combination. In series combination, charge will be same. No, Q1 maximum will be equal to Q2 maximum. No. So when charge is same, I can take any one of the charge, 6 into 10 to the power of minus 3. Alright, and I got 9 kilowatt. Now next, the last question of 2024. A capacitor of capacitance C charged to potential V disconnected from battery. Okay, a capacitance having capacitance C, potential V, charged to potential V, and then disconnected from the battery. Now if the space between the plates is completely filled with dielectric constant, what is the final charge and final potential on capacitor? Right, these are the options asked on May 11th shift 1. So what he said, in the first case, capacitor of capacitance C is charged to the potential V. Then what will be the initial charge on capacitor? So from the formula, C equal to Q by V, Q equal to C into V. One condition completed. Next, he inserted dielectric material. Then in such a situation, what will be the capacitance? Here if it is C, with dielectric constant K, it will be Kc. Right? Now next, again what he did, he disconnected from the battery. Now when he disconnected from the battery, charge remains same. No, charge will not change because battery is not there. How the charge will change? Impossible. So charge remains same. So Q dash is equal to, for second condition, when battery is disconnected, Q dash will be equal to Q equal to CV. Here what charge we founded when battery is connected, the same charge we will found when battery is disconnected. Endukante battery ledu, charge maradu. Q dash equal to Q equal to CV. So final potential, same formula we used. V dash equal to Q dash by C dash. Q dash is CV, C dash is KC, CC cancels V by K. So in options what he gave, first initial charge CV and final charge V by K. Okay. So if you like my video, please share it and subscribe it. Thank you for watching my video. Yours, Reshma Physics. Thank you.